watching the Sunday Night Show. Today, we're up for our second episode. And in this episode, we're going to know a lot of things about weather. Because today, we have Dr. K.J. Ramesh sir with us. He is the former Director General of India Meteorological Department. He specializes in weather forecasting. So without wasting any further time, let's welcome weatherman Dr. K.J. Ramesh sir. Hello, sir. I would like to welcome you to the Sunday Night Show of Oscar India. How are you doing?
Thank you. Thank you. Very fine.
So today we have many questions regarding weather. But before starting the questions, I would first like to start with your childhood. So if you please share any of your childhood experiences, like where you were a very serious student back then.
No, not at all. I was a very casual, had a very casual approach to studies, but focusing to get about first class, not 90 plus or something like that, focusing towards first class, always.
That's good. So as you are with us today, we would like to know about the history of the India Meteorological Department.
Okay, wonderful. This department is founded in year 1875 in Kolkata when during the British India. It was basically started to warn from cyclones and famines. When cyclones come, lot of damage Bengal used to face, Bengal, Myanmar area used to face, and then that was causing lot of damage. And then when monsoon rainfall is not good, it used to create a famine, because all people without agriculture, with food production, they used to migrate to other areas for job and other things. So that was the situation. To avoid that, this department was started in 1875, and from then best academicians and best professionals available in England were motivated and convinced to brought into India to serve as chiefs of meteorological department and to develop forecasting systems and observation systems in India. And now gradually we have developed into a world-class organization today.
That's why it's always better to start with the history. So out there, sir, there are many professions or what can I say, many professions or jobs like teaching, engineering, corporate, but you chose to be a weather scientist. So was this your dream from the very childhood, or you have decided this after your boards, like every other student?
No, not like that. I was not focusing like this. After my undergraduation, when I applied for postgraduate courses in Andhra Pradesh, we were in Andhra Pradesh at that time, and I applied for Usmania University, I applied for Andhra University, both the universities. And then I got admissions in nuclear physics and this meteorology, two courses admission. Okay. Then I was not knowing what is this meteorology. I went to library and realized that it is a science of weather and studies of about clouds, prediction, etc. Then I thought everybody studies nuclear physics and general physics. Let me go to this subject, and that's how I got into this meteorology.
Yes, it's always good to be different. Be unique in your way.
Yes.
So, as I said earlier, we have a lot of questions about weather. So, yes. I'm still in school. More precisely, I'm in the 10th grade. So, we have about climate of India, but it's only about 4 pages with some questions. So, I have many questions regarding climate. But, sir.
Please go ahead.
Yes.
Please go ahead.
But, sir, there is a confusion. And this is not a confusion of class 10. This is a global confusion. Even today, many of us cannot differentiate between weather and climate. So, sir, if you please clear this confusion.
Okay. Weather is a thing, it is an instantaneous condition of the atmosphere. Whenever you measure, it represents conditions of that particular time. Weather always signifies with a time of observation. So it is a dynamically changing. Every 5 minutes, the same temperature will not be there. Every 10 minutes, wind will not be the same. Wind is changing, the temperature is changing. When wind comes from one direction to another direction, it changes the temperature, it changes the moisture content in the atmosphere, and all those things changes will be happening continuous basis. Weather is an ever-changing characteristic of the atmosphere. When you average these weather conditions, then it becomes a climate. If you average all this weather data for a month, it becomes a monthly mean. And if you differentiate from that particular monthly mean with the current observation which you are making, then it becomes a anomaly. It could be higher than mean, it could be lower than mean. So when temperature becomes higher than mean, we call it as hot weather, and the deviation becomes more than 5 degrees, we call it heat wave. So everything is related to the mean conditions, that is called climate.
That was, I hope this clear explanation will clear the doubts of our viewers. So, sir, now I have a question which I find very interesting. So, in reality, we know that climate has a direct effect to our daily lifestyle. And even it influences our lifestyle to a great extent. So, I want to know how.
See, once you understood what is climate,
Hmm.
so month to month, the climate will be different.
Hmm.
Why? Because of seasons. You have winter, you have monsoon, you have autumn, you have spring. Like this, there are 4 major seasons, no? So winter will be characterized by cold weather in general, depending upon the place where you live. And summer is characterized by rain wherever you are live. And pre-monsoon means spring and summer will be a hot weather condition. So depending upon the season, everything changes. Whether it is a vegetation, whether it is a fruits and flowers, whether it is human comfort with respect to temperature changes, rainfall changes, etc. Depending upon the seasonal weather condition, your lifestyle will be different. You cook different things. You like to have hot things during the winter months. So like that, it is closely related to your day-to-day lifestyle. And particularly for agriculture, monsoon becomes very important. That is a principal growing season. If good rain comes, when all the people will be engaged, at least 50% of our population is engaged in agriculture and agriculture related operations. They are all busy with in their farms, doing the farming operations to see that good production takes place. Similarly, if good production is there, 50% of the people, they will earn at the end of the harvest season. So once they have money at the end of the harvest, they'll buy things, and that increases the production consumption pattern. So that's how the industrial output and consumer goods, everything economy is driven by the agriculture economy principally, agricultural driven economy principally. So that drives everything else. For agriculture, people work for producing good quality seeds and for producing good healthy plants. For good yields, you have to put fertilizer. So fertilizer companies will be there, and power supply is required. So coal thermal power plants got to be established, nuclear power plants, now solar power plants, all those things got to be supporting the agriculture operations. And irrigation means dams will be constructed. From the water released from the dams, canals will be there to take the water to the fields to help the agriculture. So that to drive the food production, so many 4-5 sectors are working so that country gets sufficient food. And that availability of water for food security depends upon the monsoon conditions, monsoon rainfall. That's how weather is very intimately related to our lifestyle, our livelihood, and our everything.
So we are actually dependent on the weather conditions.
Yes, particularly monsoon is a lifeline of India.
Yeah, India is a monsoon-based country.
Because food production, no, without monsoon, for 130, 140 billion population, you will have to import. Importing petrol itself, you know how much burden it is becoming now? You know, no, 100 rupees liter.
Yes, sir.
So if we have to import food, what would be the situation? All our money will go for only
Importing and
uh, procuring essential items for our own consumption. So food we are producing, that's why we are not importing, that's why we are better off. When COVID is there, government is in a position to give 5 kilos per month for individual free of cost for almost an year. That was possible because we are not dependent, we are producing our own food. So backbone of our basic economy is monsoon. So that's why we are very fortunate that we have something called monsoon.
that was very good information, sir. So, sir, as we get enlightened that the Met department does forecasting. So, my question or interest is to know that the other wings of the Met department does only forecasting, or there are some other kind of activities.
See, weather information is nowadays, weather and climate information rather, is used for several purposes. One thing is weather information is for giving idea of prevailing and anticipated weather conditions to the public in general. So when extreme weather is going to be there, some disturbed weather is going to be there, whether you call it heat wave, whether you call it thunderstorm associated with lightning, strong winds, or heavy rain leading to urban flood or river flood, and cyclone coming in coastal areas, inundating people, and all these, they disturb the lifestyle and they paralyze our infrastructure. They damage our power sector, power transmission poles. They'll be broken during cyclone time. So that will damage our power supply. And cell phone towers will get damaged. That will paralyze our communication system. And roads and coastal bridges are inundated or broken means our communication, people from affected areas, heavy rainfall zones, they cannot go to safer areas. So like this, all our lightning exposure got to be avoided. When the lightning takes place, you should have a safe shelter. So whenever disturbed weather or extreme weather is developing, if you have an indication, information about it, you can take enough response action to protect yourself. So basic functioning of the Met department is to predict, monitor, detect, and predict the severe weather wherever it is happening and whenever it is happening, and intimate it to everybody until last mile using all communication mechanisms in a fail-safe mode. Means ultimately, surely it should reach people who are likely to be affected. So public safety concern is the basic functioning of the Met department. Forecasting for public safety from extreme weather. Once this warning is there, people in cyclone affected areas, they will be taken to safer locations, they will be protected themselves, crop damage will be there, power transmission losses will be there, communication network, road network get disturbed. And before the cyclone rains and winds come, whatever harvest is possible from banana or sugarcane or flowers or other vegetables, you harvest it so that damage that will damage the standing plants, and all those preparatory actions, response actions and safety actions possible are taken before the incidence of the extreme weather associated with the cyclone. So that's how over the years about a lakh, 70,000 to 1 lakh people used to die because of a cyclone impact, when information was not reached in time and for all the people. Now we have reduced to less than 30, less than 40, less than 50 type of thing. We are evacuating 10 lakh, 12 lakh people for each cyclone safely without taking care of them till the normalcy restored. So we have mobile transformers. When power systems break down, mobile transformers will start supplying the power to the villages. So that restoration of normalcy has become quick now. We are preparing for the catastrophe. So all that is becoming possible now. It has become a practice. So early warning based response action leading to public safety of the lives first, and now we'll focus on taking care of protecting our own livelihoods, protecting our own infrastructure, so that damages for the future will be minimal. So that's how we are working. And then now taking this information, whenever heavy rainfall is coming, if that rainfall is reaching a particular river from a catchment area, and we can also anticipate inflows into a particular reservoir of that river basin will increase in 2 days, 3 days. If enough buffer storage is there, they need not have to worry. If reservoir is already 70% full, if 50% more water is coming, then you have to vacate the space in the reservoir. No, you have to release the water, so that whatever water is expected to come into the reservoir from the catchment area, so you will have enough buffer to storage. Otherwise, once it is filled, if you release, then downstream flooding will be there, people will be affected again. So water resources management, reservoir operations are dependent on rainfall information, heavy rainfall in the catchment areas. So that is the second area, helping water resources. Main one is agriculture. When rain is coming, enough rain is coming, we are advising people, okay, this much rain is coming, next week you can make preparation for your sowing, get the seeds and fertilizers, etc. At district level, we have a advisory service for farmers. It is called Gramin Kushi Mausam Seva. For crop specific advisory, farming operations advisories are given twice in a week for next 4 days, covering 4 major crops in each of the districts, so that agriculture production is sustained and it is insulated from the weather extremes to the extent possible. Agriculture and water resources. Third is the basic civil aviation, airport takeoff, flight landing, and across the flight path from departure airport to the landing destination landing airport, whatever weather is there, what is the safe area for the safe height for the flight to fly. If clouds are there, thunder clouds are there, so it will give jerks. If you fly in the aircraft, sometimes you will get the jerks because of the upward motion within the clouds. So to avoid that disturbed conditions, en route the flight path, so safe flight levels are also suggested to the pilot before the takeoff itself. So flight briefing formally is given to the pilot. So when he lands, what kind of weather will be there? In between, some sudden development takes place. Alternate flight destination is also decided for every flight, and additional fuel required for it also is accounted before the flight starts from every airport. So aviation is the original one. Weather forecasting started for aviation support only after the Second World War globally. Now we are using for general public weather and extreme weather forecast, and all these things have started. But aviation support from the Met Department is the first one which has started. Even today, 50%, we have about 6,000 odd people working in meteorological department, IMD. Out of that, 50% are working in airports only. Round the clock, 3 shifts in airports. So aviation, water, agriculture, general weather disaster support forecast. Now the new one, vector-borne diseases. When temperature is favorable, condition is there, some humidity is high, so dengue, favorable time for dengue to grow and start. And similarly, chikungunya. So many waterborne diseases like malaria. So vector-borne, waterborne. Now airborne diseases also from pollens, etc. So this is the third sector where public health related warnings. And the new one is air quality and health. Based on the wind only, based on the conditions only, temperature only, particular effluent like stubble burning, which is burnt in Punjab, brings in PM 2.5 particles to Delhi and further down to UP. Not all the time, when wind blows from that side. So you can wind-driven pollutant transport and air quality dispersion is also done based on this. And the environment now, depending upon the conditions, your drainage, municipal drainage, and as well as municipal solid waste. If it is dumped in some areas, if rain comes, ammonia comes, methane gets generated. If you have medical waste and other things are dumped there, so through chemical reactions, toxic and poisonous gases can be generated. So that weather, air quality, environment prediction is also getting linked to weather forecasts now. So there are new areas coming. Now highways and transport, railways particularly, use weather information. Depending if cyclone is coming, railway operations are stopped in that sector. If heavy rainfall is coming, more than 70 kilometers per hour wind speed is expected. In between those stations, trains are halted. So traffic management, railway transport, and highway transport now on the highways, so many toll plazas are there. Toll plazas receive information between them. Many inclement weather is there. If that is likely to inundate some bridges and more water is flowing below the bridge. So till the water reduces, traffic is halted at the toll plazas itself. Tourism is another sector now. So like that, daily year on year and newer areas of weather sensitive sectors are seeking information, like solar energy. They need solar parks need how much sunshine will be there tomorrow, day after. Depending upon that, their capacity generation can be assessed, and what kind of wind is going to be there tomorrow, day after. So wind driven energy generation is possible based on that. So many newer and newer areas are seeking weather sensitive information, and list is getting expanded year on year.
That was, what can I say? That was very enlightening. I learned a lot. So, what can I say? So, sir, now I have a question. It's not about question, it's about the condition. So, this phenomenon has become quite common for the past few years. We cannot enjoy the season in the actual season. For example, in spring, we cannot enjoy the spring. Rather, the rain follows up. But even 10 years back, people could still enjoy spring in spring. So, why does this happen? And are pre-monsoons really healthy for our environment?
See, any season, there are extreme variability. Every season will not be as per the climatological conditions, no. Either temperature will be more or more humid conditions leading to more thunderstorms and more rainfall. So there is a variability. Year to year, no Junes are same, no Aprils are same. Everything will be either hotter than previous year or colder than previous year. More drier than previous year or wetter than previous years. Wind is stronger than previous year than this year. So weather cannot be static. So year on year there will be a variability. So that variability is, it could be natural variability, year to year variability, and it could be a forced variability like climate change. Because of global warming, greenhouse gas emissions happening for several decades from 1900 elsewhere in the world. We are not responsible for today's carbon dioxide concentrations, which has warmed the atmosphere. Emissions in developed continents like America, Europe are responsible for today's warming. So like that, atmosphere is a continuous media, no? Circulation from America comes over to Europe, Europe to India, India to Japan, Japan to Russia, like that. It will be moving. Atmosphere is a continuous media throughout the globe that is continuously moving from equator to pole, like that. So there is an interaction always between atmosphere and sea, atmosphere and land. If you land 50 years before, we had only 30-40 crore population. Now we have 140 crore population. So 140 crore population need more resources, no, for living, food, schools, everything. So for that, what you do? You cut the forest, you encroach the low-lying areas. Depending upon your priorities, without really knowing, you are increasing your vulnerability. Your investment is going to be at risk. So some of the forced variability, driven induced variability is getting mixed with the natural variability. Climate change is the one. Now today, present climate change is attributable to human induced activities like emission from industrial sector, or emissions from your cars and two-wheelers, emission from your solid waste which is not properly treated. Everything is coming from one area to another. Wind takes it from one city to another city, and like that your air is becoming warmer. Particularly atmosphere is warmer because of the warming. Warming gases are there, no? Carbon dioxide, methane, nitrous oxide, all those things are there in the atmosphere because of our own activities in the past for several decades. So warming is already 1.2 degrees warming has already taken place. So 1 degree of warming increases water holding capacity of the atmosphere by 7%. 7%. That is an average increase. If you take the case of monsoon, it increase could be 20% higher moisture loading may be there into the monsoon atmosphere. Cyclone may be getting 40% higher moisture than the 20 years before cyclone. So that's how, whether thunderstorm or hailstorm, andhi, whatever it comes, it is all going to be stronger than earlier. Because atmosphere has more water, atmosphere has more temperature, atmosphere has got more energy. So it has to come out, no, to come to a normalcy. It has to come back to the mean state. So that's how we are facing extreme weather.
What I can understand is that next time I'm going to have my geography exam, I will like this explanation and I hope I will get very good marks.
Okay, all the best.
So, sir, if you please let us know what kind of technologies does the Met Department use to predict the weather conditions? And here I would definitely like to know how the weather satellite works.
Yeah, weather satellite is an important thing because if you want to describe the conditions of the atmosphere, you need to measure it, all the places. Physically, it is not possible to put your sensor to measure the conditions everywhere, no, every part of the globe, it is not possible. So that too, depending upon your money, resources, manpower, so stations cannot be everywhere. So wherever it is very much required, depending upon the earlier variability, past climate changes, past extreme weather incidents, you set up observations accordingly. But that may not be sufficient always. Now we have gone to a system called from manual observation to automatic observations. You can put the sensor anywhere, automatically it measures and transmits to your cell phone SIM. SIM card is put into the automatic weather stations. Automatically, that data is transmitted through a communication protocol that is built, automatic communication protocol. So, automatic weather stations technology has come from manual to automatic weather stations. In river catchment areas, you need not measure everything. You need only rainfall. So, only automatic rain gauges are put, and whenever river is coming and वाटर इज कमिंग फ्रॉम सब सिस्टम्स, उपनदी कहते हैं ना, उपनदी से जब पानी आता है मेन रिवर में आ रहा है, वहां कुछ वाटर लेवल सेंसर लगाएंगे, हाउ मच वाटर इज कमिंग फ्रॉम दैट स्मॉल स्ट्रीम इनटू द बिग स्ट्रीम. So these are all automated technology has come, so that whatever rainfall is coming for last 3 years, happening for 3 hours, how much water is coming into the main river channel is measured, so that you can assess from there where is the next reservoir point. So all these assessments are possible with automatic sensors. So sensor technology is the critical one for measuring the instantaneous conditions of the changing weather. That is the observation technology we call it. Once you measure, it's not enough. You should have a communication technology also. Whatever you have measured, immediately, seamlessly, without losing much time, it should. So sensor technology has to interface with the communication technology, so that immediately, without taking much time, instantaneously data gets transmitted. So that technology, communication technology, is very important. To support it, you need a captive power. Somewhere we use solar panels, somewhere you use batteries, somewhere you use regular power. We will have all the three. Whenever one fails, other one will support till regular power comes. So all these power management systems are with that. And then wherever observations are not there, that gap is filled by the satellites or oceans. So we have two kinds of satellites. One is geostationary satellite. That means that satellite is put in that kind of orbit. It moves in the same speed of the Earth rotation, so that it continuously monitors the conditions in the area the satellite camera can cover. So that is called geostationary satellites, geosynchronous satellites. It moves in the same speed of Earth, so that continuously you have. INSAT, no problem. The satellite gap filling effort for monitoring continuous weather conditions, particularly for oceans. Oceans we cannot measure physically by putting the sensors and all. So satellites is the only source to monitor the changing weather conditions over the oceans. And over the land also, wherever we don't have observations, satellite fill those gaps. Initially, satellites had only cameras to have the images, high resolution images from 36,000 kilometers height. So it used to monitor clouds and cloud movements. Based on the cloud movements, on every half an hour, we used to derive wind vectors, derive wind indirectly. How cloud motion winds, we call it, cloud motion vectors. So wind used to be wind direction and wind magnitude used to be derived based on the cloud movements from half an hour snapshots of images of INSAT. From the imagers, now INSAT has sounders which can probe and get the information about the temperature and moisture content from top of the atmosphere to the ground. So which used to be physically measured by the people on ground, now satellites are deriving that vertical profile of temperature and wind and humidity, that is nami, moisture, from the satellite in the whole of the covering area. So that satellite technology has grown so much. Now that is one category satellites, geosynchronous satellite. It moves in the same speed as the rotation of the Earth. Another set of satellites are the satellites, polar orbital satellites. They move around North Pole, South Pole in rounded manner along the each longitude. Every 5 degrees longitude, they will make a round from North Pole to South Pole. So like that, they take about 12 hours to make full round of the Earth from North Pole side to South Pole side. So their coverage area will be less. maybe 300 kilometers or 250 kilometers. If the satellite is put more closer to the Earth, like 200 kilometers height, it will be viewing range will be only 50 kilometers. So it depends on the height of the satellite. If more area you want to cover, it should be put in higher level, higher altitude. Then resolution will be compromised. You won't get the finer details on the Earth. So if you want to get full image like Google Earth, Google image is there, Google Maps. So those are the maps generated by the satellites, polar orbital satellites, put at about 250 to 300 kilometers height. So they generate the remote sensing images, and the sensors are there for that, like over the satellite, over the polar orbital satellite, you put surface wind also. When cyclone is coming, ocean surface, what is the wind speed? So those kind of sensors are also there, and ocean temperature measurement sensors are there. So satellite technology has got two kinds of technologies. One is geosynchronous satellite, which satellite moves in the same rotation of the Earth and continuously it monitors. Other one is polar orbital satellite, from north to south, every longitude it covers. So 12 hours coverage it needs to cover the whole globe. So these kind of satellites provide information, different sensors collect different information, and that information goes into our process called assimilation. You have the means of taking all the observations, manual, automated, satellite, um, and all sources of information. You have to assimilate and describe a truly representative three-dimensional structure of the global atmosphere. Over the Earth, atmosphere is there. So whatever conditions are there, in that realistic manner, you should have means of describing the realistic atmosphere. That is called assimilation process. So using that conditions, we run the models for predicting the future. Next 6 hours, 12 hours, 24 hours, next 10 days, we daily do that. That kind of daily predictions for next 10 days, we do it twice a day. Once in the morning conditions, once in the evening conditions. When cyclone is coming, we run it 4 days, 4 times a day. So for running all these models, you need high performance computing, very fast computers you need to generate, because it has to consider the whole three-dimensional atmosphere, global atmosphere, and then predict the future. So much computation is there, so much area is covered. So you need computing power, computing technology. Best of the computers from the beginning are used for weather prediction only. Any faster computer, new chip is devised, designed, and it will be tested against the weather forecasting application speed only. So many technologies are there for weather prediction and disseminating. After generating, you should have a dissemination technology. Now the web technology has come. So very quickly you can load the images, plots onto the web so that people can access, understand. So apps are there. Cell phones can access, pull that information and use it. So all sorts of technologies, many technologies, whatever technology is available in the world are put to use for weather prediction.
So that was wonderful, and everything about satellites is wonderful. But sir, as you said, technology uses electricity. What if the electricity is not there during cyclones? At that time, what we will do, the common people?
Common people will have a problem, but for operating our own Doppler radars in the coastal stations, operating our own weather stations, operating our own automatic weather stations, high wind speed recorders, and aviation weather supports in airports, we have an auxiliary power. Generators will be there at least for, we have enough fuel stored at least for a week. When power even doesn't get restored for a week, our operations won't be affected. For each Doppler weather radar operation per month, we will be paying about 50 lakhs of electricity charges. India has 45 Doppler weather radars in operation. You can imagine how much money India Meteorological Department is spending.
I can imagine many zeros.
Each Doppler weather radar installation, power consumption cost itself is about 50 lakhs per month.
So, sir, does the Met Department have any plans or new aims for 2022? And the thought which worries me totally is that is there any calamity which is going to take place? Not only about Bengal, about any state.
You see, now we have to be ready for monsoon, heavy rains associated with the monsoon. In about 15 days' time, already up to Andamans and up to Myanmar, monsoon is there. In about 15 days, Bangladesh, Northeast India, and West Bengal, they will start receiving monsoon rains. So monsoon will bring heavy rains and associated problems, inundation and damaging mud walls and poor houses. And but it is required for our agriculture operations, rice plantation, rice growing, jute, etc. And then monsoon heavy rains, we have to be ready, and warnings are there. So if you listen to the warning and take care of yourself, you can protect. Life protection is first important, and living in safer conditions is second priority. And then stable power supply is required for students, particularly to prepare for their exams, studies. Throughout the year, you have to write some competitive tests once you complete your undergraduation. So without power, those challenges cannot be met. So there are things. Monsoon is there, and following monsoon, cyclone season comes. So Bengal or India, we have to till October will be monsoon related extreme weather and cyclone related weather. We have to be watchful about.
I see.
Okay.
Yes. So I have already taken most of your time, but this will be the last question. What measures can be taken by the general public to save our environment and minimize the effect of this weather changing?
In the atmosphere, already whatever warming is there, those driven extreme weather events and impacts have to be borne. No escape from that. But what we can do is we can minimize the future warming rate of the atmosphere. Warming of the atmosphere rate from now onwards can be minimized. So for which you have to use less fossil fuels, whether it is petrol, diesel, and go for greener electricity, use less pesticides and chemical fertilizers for your food production, so that methane production is minimized. Go for organic cultivation and soil organic carbon, because soil and plants can absorb carbon dioxide. So you have to put more plantations. So all these steps are possible.
I have learned a lot about climate. Not only me, everyone who will watch this video will learn a lot about climate, and we can hope the persons watching this video will surely take the measures you have said. So I'm really thankful to you, sir, for spending your this valuable time with us. Really, Team Oscar is honored today. This was
Okay.
this was all I had to say from my end. If you have any message to share with
All
our
the best.
viewers, you can.
All the best, and God bless you.
Thank you, sir. With this,
Protect yourself and protect environment.
yes, sir. Sure, sir. With this, we'd like to end our today's show. Thank you. Stay safe, stay healthy, wear a mask, use sanitizer.
Wonderful. All the best.
Thank you, sir.